Help you a little bit with 7.3, some of the problems that we did for homework. I'm going to start on this side because I think the other side was pretty straightforward, other than a few missing measurements maybe that were trying to be confusing. So we're looking at this, and it says you're given the length and width of three rectangles, which two are similar. If this is confusing to you, then just make three rectangles, and I think pretty quickly you'll see what the problem is asking. So basically you're comparing the ratios here to see if the ratios of the sides are the same. Well, you can write it out, 5 over 7, 8.5 over 11, 10 over 14. You do 5 over 8.5, is that the same as 7 over 11? Or you can look and see, okay, I see double 5 and you get 10, double 7 and you get 14. That doesn't work here with this one in the middle, so A and C. I'm going to try to do the same thing here again, and I notice this is weird. I don't know why that there's centimeters and meters. They're trying to throw you off. So really this would be 100 centimeters. So pretty quickly you can see, I'm trying to compare feet to centimeters. I mean, I can still have a ratio, so I'm hoping that there's a common scale factor here, and you notice 4 times 5 is 20, 5 times 5 is 25, so A and B there. In the last one, again, some mixed up units. We have feet and inches, so this would be 36 inches, 15 inches. You want to get them to be the same units. So I'm already suspicious about this one, so I'm going to check and see. 3 times 2 is 6, 15 times 2 is 30, A and C. List all the pairs of congruent angles and write the statement of proportionality for the figure, sometimes called an extended proportion. So the angles, angle G is congruent to angle T. Angle R is congruent to angle F. And angle M is congruent to angle D. One thing that I do sometimes is just write GRM, TFD, and then go back and fill in the symbols so I got things lined up. You could do that with 4 sides as well. So those are the easy ones. Those are the angles. For the sides, just make sure you don't look at the picture. Look at the similarity statement, because the picture can be flipped. So GR over TF, RM over FD, and GM over TD. And you could have those flipped, you could have it in a different order, but that needs a match-up line. We're not going to do the rest of those there. Determine whether the polygons are similar. If so, write a similarity statement. They have to have congruent angles and sides proportional. So I know if these two angles are equal, then the third is equal by the third angle theorem. So now I'm just going to see, are the sides proportional? 9 over 6, 12 over 8, and 15 over 10. Those all reduce to 3 over 2. So the scale factor is 3 over 2. So now you just need to write a proportionality or a similarity statement. RAX, go in the same order, TNM. Always just follow your angles just like when you did congruent statements. Same thing here, you're going to have a little more choice if you have a rectangle, but it's worth checking. So let's say 10 over 8 equals 6 over 4. 10 over 8 is 5/4. 6 over 4 is 3/2. So those are definitely not similar. You save yourself that work. Gone. Alright, so we do have similar polygons down here, and it's worth checking. A, B, C, D, similar to G, H, I, J. So they're in the right order, so you can look at the sides as they are. So find the scale factor. I just need any two sides, but I'm going to write a proportion over here, and I know 11 over 5.5 equals 8 over y equals 11 over hi equals x over 8. And that's your extended proportion, because we can use that now to find either of the x or y. They're going to ask about x and y over here. We know the scale factor, so you can take the 11 divided by 5.5 and get the scale factor, which is 2. So my scale factor is 2 to 1. The scale factor for the other way around would be 1 to 2. Now I can just find my x and y values. Now this is a nice easy one. Stuff's just doubled. But if it wasn't, you'd say I can look at these two to find y. So there's a proportion there. And then I could look at this one and this one to find x right there. So we know that x is going to be 16. They're in the 2 to 1 relationship. Again, you could cross multiply. 5.5 times x equals 88. And y would be 11y equals 44. So y equals 4. Now this was nice because they were 2 to 1. It's easier. Find the perimeter of each polygon. So I'm going to put my numbers on my picture. Make sure my picture is cleaned up a little bit. That's 4. That's 5.5. So the perimeter, 16 plus 11 plus 8 plus 11. So this is 22, 30, 46. And this would be 8 plus 5.5 plus 4 plus 5.5. So 15, 23. The ratio of the perimeter is also 2 to 1 because they are double. And we talked about it in class. The ratio of the perimeter is the same in similar triangles. Okay, one more will be the last part of this activity we didn't get to in class. We're going to talk about next week, but if you need a little extra help. I have a similarity statement. I have some variables. And so this is what I was talking about. If you just write your proportionality here, so WL over QB equals LJ over BV equals WJ over QV. And I'm not even looking at the pictures, I'm just writing those because now I can go to the picture and say, well, WL is X, QB looks like it's 5 because they're congruent, LJ is also X, and BV is 5, WJ is X plus 6, and QV is 8. So I just took out all those and put in numbers here. So now I have a proportion I can solve. I'm only going to use 2 out of the 3. So 8x equals 5x plus 30. Don't forget to distribute both. And then don't go committing some silly algebra error here. So x equals 10. So when I go plug it back in, I know I have 5, 5, 8. This is 10. This is 16. This is 10. And they're asking for the scale factor, which would be 2 to 1. Okay, so again, I would encourage you, like especially on this one, we don't know these sides are equal. Don't just assume that they're equal. Set up your proportions. This would have 4 proportions. And then you can pick the 2 that you want. That's long enough for now.